It's not very clear, is it?
Let's just.
But you're being asked to find calculate the perimeter of the frame. So you're being asked to. It's a very normal question, very common, which is you've got to find the curved length, so the arc length, and you have to find the straight lines. Now the straight sides are easy enough. There's not an issue there. The main maths is actually finding the arc, but actually, what do you think the biggest mistake is in this kind of question?
Counting the sides twice.
Actually, not counting them twice, not counting them at all.
What?
Huh?
Thinking that that'd be the center. It's not.
No, the biggest mistake I'm thinking of, if you're asked to solve this problem, because the main problem is this arc length, yeah? That's the only real bit of maths that you have to do. And then you get that, and then you don't reread the question and see what the actual question is. So you forget to do these bits. Now, quite often the question will be just the ice cream cone type shape, and people forget to add those two lengths on. It's the biggest mistake is actually just forgetting to add on the final lengths. Yeah, working out this arc is not that hard, right? So we've got frame mirror, shape of a rectangle, the curved top in the diagram, the vertical sides of the frame are 50. The top is an arc with central angle. So that's the bit of information you needed. So we have, just to redraw, an arc where the angle is 97 degrees. So all you need is that length. That's the first bit of maths that we have to do. So how do you find that?
Angle.
So this bit here is a fraction of a whole circle, right? That fraction is 97 out of 360 of the entire circle, but we're not after the entire circle, we're after the circumference only, which is that fraction multiplied by
2 pi r. Nope.
2 pi r, or pi times d. D of this circle, well, you know that this length here is the radius of the circle. Okay, so that would be the 20. So the diameter, pi d, would be 40, or 2 pi times 20, an idea. Okay? Because this arc would be, if you were to continue the entire circle, would look like this, yeah? So,
I'm very confused.
why? What are you confused with?
Because if the diameter of the circle is 30,
Why is the diameter of the circle 30?
because,
It's not.
okay.
That is this length, yeah?
Oh, but that's not the diameter.
That's not the diameter of the circle. That, if you look at my drawing, look, the diameter is all that length, and this keeps going out even further, yeah? Well, actually, this is wrong, because that should be more than a quarter. Yeah, more than a quarter of the circle.
A quarter would be 90.
So it would actually be, I've not drawn it very well, but you get the
Oh,
idea.
yeah.
Yeah.
The drawing.
My drawing's not very accurate, I've just given it a rough. So 97, more than 90. But yes, the circle would carry on even just a little bit more.
Oh.
Yeah, so this line is not the diameter. It's always these lines are the radiuses of the circle, right? So what's that? Have you worked that out? Maya was doing it, I think.
33.86.
Oh, yeah, 33.86.
33.86 centimetre. And this is what I was saying is the issue, because people go, there you go, move on, question 9. But that's not the answer to the question. That is just the arc. So the perimeter of the entire shape is 33.86 plus 50 plus another 50 plus 30, yeah, plus 130, which is 163.86 centimetres. Right, so you're looking a bit confused? Or...
No, I'm good.
You good?
I'm just like.
Cool.
Do 9.
Can we take earpods out?
Wally?
Well, I'm teaching.
I thought, okay.
No, I'm not gonna. So, any ideas where you would start a problem like this?
Finding the line. Oh, never mind, that's a laser.
Find the angle.
Okay. Right, so you need to work out the fraction of the whole circle. That's always the step, isn't it? So we could remember what we've got. We've got theta there. Let's just see whether that's a way forward. So theta divided by 360 multiplied by, well, we're told what piece of information? The arc length. So that is pi times d, right? D in this case is 24, good. Right, that would give you
what's the
3 pi. So I've just written the formula out that you're used to using, right? I've not tried to do anything with it yet, I've just put in the information I know. That is a very common approach to lots of the problems that you will have when you've got formulas to use. Don't try and do anything until you've actually got the formula written and everything put in that you need. Alright? So what do we do now?
Find the major arc.
How?
What didn't
By finding the entire circumference and then subtracting 0.
But once we found the entire circumference,
Oh.
I've solved the problem.
Well, never mind then. Oh, wait, we never, what?
But what we can do though, if you remember, the theta over 360 is a fraction of the circle, yeah? That should be the same as 3 pi divided by, nope,
12.
what's
Like
the whole
120?
circumference?
No kidding.
No.
3 pi 40. Oh, 2. No. Yeah, r
Pi
squared.
circumference.
R.
Pi, 2 pi r or pi d, yeah? What's pi d?
Pi 24.
Alright,
Can
so
we just-
let me
can we
write
just-
it. I've done this in 2 different ways, and I'm going to let you. So,
Don't
come on, computer.
do we even need to do this to find the circumference of the whole circle?
That was my question too.
Can't we just use the diameter and the formula and just get the whole circumference in one go?
Yeah,
Because we have the radius, we just
then just get the diameter and do pi d.
Okay.
yeah.
So what would you do?
Why? Okay, well I don't remember the formulas. off
Wait,
by
24
heart.
pi.
Circumference
answer.
equals
Yeah, 24 pi is the answer.
pi.
Because it's in terms of
Yeah.
pi.
So
Oh,
just
Well, so what is
24
all
times
Oh,
pi times.
but it took someone to actually say it, no?
Yeah.
So
Okay, but like,
75.
so we don't. This isn't even relevant. to
No, the reason why it is relevant is because sometimes it won't be quite that simple.
Okay.
But what I've kind of done there is if you're in an exam and you don't know where to start, what's the place to start?
Formula.
The formula. Put in what you have. So let's just see whether we end up with the same results. Yeah? So you've got here the circumference of this whole circle is, you've got 24 pi, right? Pi times the diameter. You've got that. Did I even need?
No.
Okay.
But the one on the right you might need.
So do I get the same result using these other methods?
Yeah.
I mean, if
sure,
we're right,
whatever.
you should.
Okay, so let's just check with the formula. Does this give me this?
I have no. It might not. Well, I trust our answer better.
Well, what would this be used for?
If you want to find a fraction.
Want to find what?
Fraction.
Oh,
The angle that makes it, yeah?
Yeah.
Alright. Is this, well, I'm just sort of getting you to analyse the situation. Right, what have we got? You've worked out the circumference really quick and easily, right? Because you finally looked at it and went, I've got the information I need, I don't need anything else. This information I can use if I want to find the angle. Do I need to find the angle to find the circumference? Okay. Alright. Says calculate the circumference of each whole circle in terms of pi. What about this one then?
What?
I can't even tell what's
pi
there.
r.
It's in your book.
Doesn't
Yeah,
give you
show
any
us that.
values?
This is an L, this is an R, this is a theta.
Why is it reversed?
It's just
Oh, wait,
two.
no, that's the
It's
wrong
just
one.
2 pi r. It's
pi
just the
r.
equation.
Yeah.
It's nothing. It's just not the answer.
Well, let's see where. Use the arc length to work out the fraction of each circle that is shaped.
Oh.
So what's this?
Write down a general formula for finding the angle of a sector given the arc length L and the radius R.
So it doesn't want an answer, it just wants us to write the formula.
So that's what we're trying to develop here. So it says use the arc length, right? Use the arc length to write down a formula for finding the angle.
So we did that for the first one.
Well, we haven't quite done it. We haven't finished it yet.
No, we have.
Where am I? What? Oh, okay. So I've got this. This is just the circumference. This is. So this is also it, yeah? Which one would you use, or are they the same thing?
They're the same thing.
Why is this the same as that?
Because I said.
I times 24.
It's just rearrange.
Because if I put, yeah, alright, because I've got 3 pi, divide by this, yeah, gives me this. So I can either express it in forms of the formula, or I can do it because I understand about fractions. That's the fraction of the angle, that's the fraction I've been given of the arc length. So if I asked you to now, let's say, use this one to come up with a general formula for theta in terms of L, R and theta. So theta equals
360 times bracket 3 pi divided by 24 pi bracket.
no, that's only for this
L.
one in particular.
L.
Oh.
L over
2 pi
R.
r.
2 pi r.
2 pi r or pi d, up to you. So would that simplify to 360 L over pi d?
Yep.
Without needing the brackets. Everyone with me again?
Yeah.
So is that just again doing this fraction of 360 degrees again? So do you remember you would use the angle as a fraction to find the fraction of the circumference or the fraction of the area? Basically all you've done is use the fraction of the circumference to figure out what the fraction of the angle should be.
So you just find out what, basically,
Go on.
you just use the entire angle, right?
So this whole thing is about fractions. Okay? The whole thing is about fractions. Alright. What do you think area is going to be like?
Difficult.
Horse.
Harder.
Amazing.
None of those.
Isn't it?
Easier.
Not that either.
Same.
Exactly the same.
Wait. So for the answer.
Because the principle is fractions, right? So instead of us having, a fraction of the circumference, we would have a fraction of
The area.
the area. Yeah? So theta using the area would be 360 multiplied by, because that's the whole angle,
A over
area of the
pi r.
sector, divided by pi r squared. Yeah? So this is the fraction, it's this area out of the total area, multiplied by, if you think back to the formula for area, it's pi r squared multiplied by theta over 360, yeah? Do you see the similarities? or the arc length L is pi d times theta over 360. Is that right? Yeah. Compare. Try and think of the similarities, what the process is. So this is when I know the angle, I know the fraction of the whole circle that I have based on the angle. I apply that to the area to work out the sector area. If I know it, I can apply it to the circumference to find the arc length. If I do the other way round, I just work out area or arc length as a fraction of its total and multiply it by the angle to figure out what the angle would be. Right, so really there's only one thing we're doing. It's fractions of, and that's it. So let's have a look at a question then, shall we? Should we do this one?
It's what area? Or
Don't know, I haven't read it yet. Let's see what it is, because it's all the same thing, so it shouldn't matter. Right. This projector's really bad, isn't it?
we're all bad.
Okay. Let's do that. Oh, that didn't give me what I wanted. So you're being asked to find, here's the, you know the question, right? So A and B, this is 11.8 square centimetres, that's the area of the sector. Okay, it's 11.8 centimetres squared. What does that say? Can you read that real quick? 7.5 centimetres. Right, find the arc length AB. Is that all the information I have? Find the angle in the sector, then find the arc length. Okay. Right. Find the angle in the sector. What's the angle?
We use the,
So we want to know theta, so we're doing 360 multiplied by, what information do we have?
we have the area.
The area is 11.8 out of, how much should it be? Pi multiplied by 7.5 squared.
15. Wait,
No, that's for the circumference.
Oh.
This is area. We've been given the area. Now, the information we've got is the area, so quite often a question will be area to angle to arc, yeah? Or other way around, you kind of get given one, have to go through the angle to get to the other one. Alright, it's a common question, you'll see it over and over again. Just about how do we do that now? What mode do you have to make sure your calculator's in?
Second?
Normal mode.
Yeah, just degrees. I don't really do it.
I was hoping someone would say degrees rather than normal.
There's a degree
one.
mode. I don't even
But
know what it is.
actually, why doesn't it matter in this case? What are we not doing?
Finding something.
Finding.
Yeah.
Subtracting.
When is the only time you need to worry about having degree mode rather than radian mode?
Trigonometry.
Trigonometry. We're not doing trigonometry.
What is radian mode?
When you're dealing radians. So this whole thing, by the way, is so much better when you work in radians rather than degrees. We're not there yet. That's when this is not 360, it's 2 pi. There are 2 pi radians. But I'll show you that in a sec. Well, what's the answer to this? So, worked out the angle. Now for the arc length, total arc length multiplied by the fraction. I'm doing this the other way around than the formula, and we did yesterday. I hope that's not caused you any problems. It could do. So put it back the other way if you prefer. What do you get?
3.15.
3.15 centimetres, which makes some sense. Look, 7.5. I know it's not to scale or anything, but so that's my outlet. Right. Make sense?
Is that pi? 3.1468.
No?
No.
No. 3.15. Did you round it?
Yeah.
Could it be pi? 3.15 you said?
It's not.
If you hadn't rounded it, could it have been pi?
Probably.
Well, I'll tell you what, let's have a look. Do you remember I said about radians being easier? Let's do it in radians. Now, just as an introduction to you, you don't need to worry too much about this. A circle is 360 degrees. Measured in a different way, it is 2 pi. So this is degrees. 2 pi is in what we call radians. So how many radians make up a whole circle? 2 pi, which is in normal numbers about 6. A little more than 6. Right? So there are only 6 radians in a circle. And then it goes on forever. So why is radians easier to do when you're working with this? If it's a decimal that goes on forever. Well, let's look at this. What happens if I try and work this out? So theta is not 360 times, it's actually 2 pi multiplied by 11.8 divided by pi times 7.5 squared. So what immediately happens? The pi's cancel. So now you have theta is actually 2 times 1.8 divided by
11.8.
sorry, 11.8. Can you do that for me? What do you get?
It's the same answer.
Christian, can you duck down one?
It shouldn't be the same answer.
It's not this. It's
Okay,
very,
don't.
very similar. But it's not
Oh
the same.
yeah.
This one is 3.146, and the 6 is just recurring.
What's the angle answer?
Why did I always get like some weird answer?
Same answer. Oh.
I got 0.41.
Okay.
Yeah, I got that too.
Yeah, I got that too.
0.41.
9.5555555.
Okay. Now that actually makes perfect
That
sense.
number.
Do you remember I asked you in trigonometry to change your calculator to radians and do sine of something in radians instead?
Don't remember this.
Don't remember doing it. Okay.
Maybe
Well,
not.
when you do, I did do it because I always do it to show you if your calculator is in the wrong mode, you will get a decimal or a number that makes no sense for an angle.
I don't want to change.
All right. So you should be able to tell me nice and easily, right? Super easy. Now, sine of an angle is equal to a half. What's the angle?
180.
45.
Sure.
180.
Oh no, no, no.
No.
45. That would be 1√2.
60.
Okay, so we've got our special, so that's 60, this is 2, 1, this is √3, so it's actually, sine is opposite over hypotenuse, 1/2, so it's actually 30 degrees, right? I'm so glad we did all that work. So get on your calculators, just check then, let's use our calculator to confirm that and do theta is the inverse sine of a half, please. Do that for me. What do you get? Everyone do.
30.
Pardon? 30. Right, so we've confirmed. Change your calculator to radians mode.
I don't know how to
You
do
should
that.
have a DRG button at the
Oh, I
top
figured it
somewhere.
out. Oh, I did it.
And when you do that, you'll see it says DEG or RAD or GRAD. So you can change. So change.
I only have flow, psi, and ink.
That's something else. No? Have you got
What
the
type of
DRG button?
Japanese name do you have?
You all have
Oh,
that.
I was on second. Oh.
Yeah. Let's carry on. So we've got an angle like this.
In radian or in?
Yeah, whatever. You can put it back to degrees. If you like. But let's go on. So this is where we were. So we've got degrees. That's in radians. Now you know it means the same thing, right? Same actual space, but it's a different, this is radians, okay? This is degrees, we've already got that. So the next stage is to do the arc length is still 15 pi, but this time multiplied by, instead of that, we want 0.4196 divided by 2 pi. Again, pi's disappear, alright? And we just have L is 15 multiplied by 0.4196, and you get
3.147.
We still rounded, didn't we?
Yeah. If you use the.
Look what we're getting closer to though.
It's the same.
Hi.
Whoa.
If you use the exact measure, just do put 1, 4, 6, and then 6, 3.
Yeah. Okay. So it's the same, you get the same results for lengths and things by using angles in a different way. Alright? But it's got that round thing. But anyway, we've done it. We started with some area information. We went from area to figure out the angle, and then we can use the angle to figure out the circumference. The same thing can happen in reverse. Alright, and that's a normal type of question for you. Alright. So you now pick another question. Go for it.